Welcome to One Chemistry. Always try to do your best. Now we are going to see Diels-Alder reaction. We will see some basics, mechanism and 25 fully solved net problems. What is inside this video? First we will see what is Diels-Alder reaction, then we will see types of diene, types of dienophile, then we will see controlling factor of its very important thing. The reactions are cyclic or acyclic, stereospecificity of the reaction, steric effect influence, and S is configuration requirement and regioselectivity. Finally, we will see 20 fully solved problems from UGC, NET, GATE, JAM and TAFR. At first, we will see what is Diels-Alder reaction. The Diels-Alder reaction is reaction between diene and dienophile. One conjugated diene is there and dienophile is there. Both form kind of cyclic transition state, form cycloaddition product, which is 6-member cyclic product, which is alkene there. Here 2+2 addition also possible, but rare due to ring strain. Here Lewis acid also can be a catalyst, but in rare cases. We will see the diene first. Diene should be electron rich. Diene should be in S-cis form. Rigid rings are always better because it holds the S-cis form better. Then diene should be steric free. Here I given many dienes for your understanding. All are diene. Here I categorize good versus bad. Here I mention only bad diene with reasons. Bad dienes are normally steric system or bad S-trans system or aromatic system. Then let us know the dienophile. Dienophile should be electron deficient, often come with electron withdrawing group. It can be simple linear acid or anhydride or cumulative double bonded compound or a quinone kind of architecture or alene analogues or just dicarboxylate ester. Here it can be S-cis or S-trans or alpha beta unsaturated ketone or alkene with multiple electron withdrawing groups. Multiple dienes are known in the literature. Then we will see the important thing, requirements for the Diels-Alder reaction. This is very important to understand the reaction fully. The diene should be with perfect tetrahedral angle, then only the fusion will be effective. Here you can see the ring size increases, the reactivity decreases because of loss of tetrahedral structure. Here the important fact you have to know here is 5-member is faster than 6-member because strain relieved during the cycloaddition. Linear versus cyclic diene. Linear diene is little bit less reactive when compared to cyclic because cyclic is very rigid, can maintain the S configuration better. Here addition is S-cis addition. If the compound come with S-trans also, it will convert to S-cis. S-cis means single bond cis, single bond trans. Here I given some examples with S-cis configuration. You can see conjugated diene. In ring system you cannot convert S-trans to S-cis, so it don't react. Same with fused ring system. By looking at it you can understand diene have many choices. So the fact here is Diels-Alder reaction happen with S-cis diene. Here another requirement is diene should be with electron donating group. It can be either mesomeric or inductive. Diene reactivity will be more. Obviously electron withdrawing group decrease the reactivity. So if you look at the electron donating group increase the reactivity. Second thing is aromaticity. The more the resonance, lesser will be the reactivity because electrons are not static. The fusion will not be effective. Moreover, the more resonance, the system will create more thermodynamic stability. It won't undergo reaction. Then the ring with heteroatom, thiopene, pyrrole and furan. Here reactivity is inversely proportional to electronegativity because electronegativity make the ring electron deficient. It will be bad for our reaction. Another important factor is steric effect. Normally the alkene convert S-trans into S-cis form, but if the groups are bulkier it is not possible. So bulky groups prevent the conversion of trans to cis. It will also prevent the planarity. So there should be a minimum steric effect required for the reaction. Then the important fact, syn addition. The cycloaddition is a syn addition, meaning the approaching atoms are approaching the same plane. So the resultant product will be on same plane. It is called syn addition. Here both carbon are added at the bottom, so hydrogen will come above. So the addition is syn addition here. Then the endo product. If you have cyclopentadiene with alkene, you have bicyclic system with the endo product, not the exo product. It is also called endo role. Endo is the major product and it's kinetically controlled. Here endo is kinetic, it is steric, quicker, low temperature product. Exo is exactly opposite, thermodynamic, less steric, slow, high temperature product. The reason is rise from orbital overlap. Endo product have lower energy. Then the important fact, religious selectivity. Always ortho para is favor rather than meta. Here just see diene and dienophile. There are the two possibilities. Aldehyde and methoxy group you just see. Ortho product is major, meta is minor. If you look at the second example, same thing is possible, para or meta. So para is major thing because of the same reason. The reason is orbital coefficient. If you are interested, you should study separately. Let us learn from the problem. Here I given 25 step-by-step solved problem from NET, GATE, JAM and TAFR competitive examination. Let us see the first problem. First problem they given the three different diene. They are asking the reactivity of Diels-Alder reaction. So you have to know which one reacts faster than others. The question is really about structure of the diene versus reactivity. The answer is A. Let us see how. Here the diene requirement should be rigid and it should be S-cis form. If you look at XYZ, the diene should be S-cis form. So if you look at it, the Z1 cannot have S-cis form because of the steric effect there. If you look at the Y, it cannot form S-cis. Y is least reactive and X is more reactive. The order is X, Z and Y. The fact here is Diels-Alder reaction require S-cis bond. Then let us look at the next question. Here they given the diene and cumulative diene in presence of titanium tetrachloride, which is Lewis acid. They ask you to find the product. The products can be bicyclic system or fused 5-member and 4-member system. And you have to also find endo or exo nature or syn or anti nature. So from the question to products, you might realize the question is really about ring closure versus stereochemistry. The answer is C. Let us see how. In the reaction, if you look at the dienophile, you have two double bond, you might confuse which one reacts. Normally dienophile react, meaning the alkene attached with COMe, which is electron withdrawing group, reacts. So 6-7 reacts and you have final product. So only endo is formed, so the answer is C. Then let us look at the next question. You have diene and maleic anhydride in presence of heat. You have to predict the stereochemistry here, where the hydrogens in the connection positions are syn or trans, or the ring size is different, whether it is 6-member or 5-member, or 5-member and 4-member. So from the reactant to product, you might realize the question is really about stereochemistry of addition. The answer is B. Let us see how. Here you have 4+2 cycloaddition. It's a typical Diels-Alder reaction. So you might already know Diels-Alder reaction is a syn addition. So both carbon are added in the same phase. So hydrogen should be syn to each other. Either you can view from above or below. The answer will be same. The answer is B. Then let us look at the next question. You have cyclic diene and dienophile with ester. You are heating it up. They ask you to find the stereochemistry of product, whether substitutions are cis to each other or trans to each other, cis endo or cis exo. So from the reactant to product, you might realize the cycloaddition and position of COOCH3 is important here. The answer is C. Let us see how. Here if you look at diene and dienophile, chances of bicyclic ring formation, you might know the endo rule. Endo rule always says that endo product is favored in the cyclic addition reaction. So it's a kinetic product, even it is sterically hindered. So always endo product is formed during the cycloaddition reaction. Then let us look at the next question. The question is really about number of compounds can undergo Diels-Alder reaction. Here 7 different dienes are given. You have to guess which one will undergo, which one don't undergo. All 7 are different in the structure. So from the question to answers, you might realize the question is really about structure versus reactivity. The answer is B. Let us see how. Here totally 5 compounds can undergo Diels-Alder reaction. Here the fact you have to know here is SC's form is always decided for the Diels-Alder reaction. So either way you bring it, it will convert it into SC's form. Irrespective of starting metal, it will convert to SC's form. If you look at our all 7 compound, the fourth one is in S trans form because it cannot flip the ring, so it always stays S trans, so it won't undergo. Similarly, fused ring system, you have diene which is on separate rings, so it is also S trans, it cannot convert into S's. So totally 5 compounds can undergo Diels-Alder reaction. So the answer is clearly B there. Then let us look at the next question. You have maleic anhydride plus diene and you have the product. Here they are asking order of reactivity of diene. They given the 3 different diene, one with chlorine, one with methyl, one with methoxide. So you have to find which one reacts faster. So from the question to product, you might realize the question is really about diene versus substitution. The answer is A. Let us see how. Here the fact you have to know here is electron-rich diene can undergo Diels-Alder reaction effectively. Another factor you have to also know that mesomeric effect is greater than inductive effect because mesomeric donate the full electron, inductive donate the partial electron. Obviously O-methyl group reacts faster because of mesomeric effect, then methyl reacts, finally chlorine reacts. So the answer is A, which is 3 faster than 2 and 1 is the least one. Then we will see the next question. They given the 3 different dienes A, B, C. They are asking you to find the reactivity of diene. Here the dienes are differ in the tertiary butyl substitution. So you have to find which one reacts faster, which one reacts slower. So from the question and possible answers, you might realize the question is really about tertiary butyl group versus reactivity. The answer is A. Let us see how. Here major requirement for the Diels-Alder reaction is SC's form. Here tertiary butyl group is bulky, it don't allow the SC's formation. If you look at the A, it has one tertiary butyl which is exactly near the double bond, so it won't allow the SC's. If you look at the B, butyl is bulky but it is away from the reaction center. It will be less affected. If you look at C, it is very steric, so C will be least, A will come next, B will be the faster one. Then let us look at the next question. The starting metal they given the quinone kind of compound and the substituted diene. The substitution can be heteroatom, carbon, oxygen or sulfur or nitrogen. Here they given the possible product. They are asking activation barrier trend in the reaction. You have to guess which one have high, which one have low. So from the question to possible answers, you might realize the question is really about Diels-Alder reaction versus heteroatom. The answer is C. Let us see how. Here we already seen the electron richness is required for the Diels-Alder reaction. The oxygen will be more electronegative, then come nitrogen, then comes sulfur. So the reactant will be reverse of that one. Sulfur is higher, nitrogen will be the next, oxygen will be the least one. The C is not at all aromatic, it will come very least case. Here high electronegativity don't allow the electron to participate in the ring, so poor the reaction. Then let us look at the next question. They are asking most reactive diene for the Diels-Alder reaction. Here they given with the trick, you have to draw the structure. You have to draw 1,4-hexadiene, whether it is 4E or 2E4E or 4Z or 2Z4Z. So from the question and possible answers, you might realize the question is really about configuration versus reactivity. The answer is C. Let us see how. Here if you draw the structures nicely, 4E and 4Z, it is not at all conjugated, it won't undergo the reaction. If you look at the C and D, both can be the conjugated diene, but if you redraw nicely, C will have SC's configuration. D is there, but 1,6 carbons are floating due to the steric effect. So the C here is only our possible answer. Then let us look at the next question. The question is really about diene does not undergo Diels-Alder reaction. They are given the 6-5 member fused system with conjugated diene. All fours are different in the position of double bond. So from the question and possible answers, you might realize the question is really about configuration versus reactivity. The answer is B. Let us see how. Here as we seen, the important fact here is S form. So the diene which will be with S form can undergo Diels-Alder. The B one which don't have S form, since the ring is rigid, it cannot isomerize to cis. So only B is the compound which will not undergo Diels-Alder reaction. So our answer is clearly B there. Then let us look at the next question. The starting metal is A and malic anhydride. You have to have Diels-Alder product. Take given the 4 different diene, which is cyclic one and the multi-branched one and the linear one, are just a simple diene. So you have to find the reactivity order among them. So you have to find which one is higher, which one is lower. So from the question to products, you might realize the question is really about structure versus reactivity. The answer is B. Let us see how. Here also the same fact, you have to have S form with less steric effect. One will be the best one because less steric and very rigid S configuration. If you look at the two, it is trans as well as steric. It will not convert into S's. If you look at the third one, it will convert and rotate. So it will be with electron donating group better than any other. If you look at the 4, it's a normal one. If you look at the order, first one will be higher, then come third, then will be the fourth, finally the least one, which is sterically hindered alkene. So the answer is clearly B there. Then let us look at the next question. The starting metal is cyclic diene with ester there. They ask you to find the product. Here they given the endo versus exo product. Even though this kind of question we already seen, these things are repeating in all over the exam. So you have to guess whether the products are endo or exo or cis or trans. From the question to product, you might realize the question is really about endo versus exo product identification. The answer is C. Let us see how. This fact we already seen the endo rule. Endo is major and it is a kinetic product for Diels-Alder reaction. So endo is the major product here. The reason is originated from orbital overlap. It will have lower energy for this configuration. So the answer is C there. Then let us look at the next question. The starting metal is cyclic diene and you have malic anhydride. They ask you to find the product. Here also the question of rigid carbon will come or not, or a fused tricyclic ring come or not is the question here. So you have to play between the possibility and syn and trans hydrogen. So from the question and possible products, you might realize the question is really about stereochemistry versus Diels-Alder reaction. The answer is B. Let us see how. If you fused with malic anhydride, you have rigid carbon and hydrogens are syn to each other. If you read it nicely for 2D, you will have answer B. Here the fact you have to know here is Diels-Alder reaction is syn addition. Then let us look at the next question. They are given the 3 different diene. They are asking the reactivity. The similar kind of questions are coming from GATE and NET and JAM exam. So you have to guess which one will react faster, which one reacts slower. So from the question and possible answers, you might realize the question is really about structure versus reactivity. The answer is A. Let us see how. Here the prime requirement is S form. As we seen already, the rigid rings are better with S. But if you convert Y into S, you will have steric effect there. So Y will be the least one, X will be the better, Z will come middle. So the answer is clearly A there. Let us see the next question. The question is really about the diene can undergo Diels-Alder reaction with malic anhydride. They given the 4 different diene. As we seen, we have to find the reactivity among them. The diene can be exocyclic double bond or a side chain conjugation or different ring cis double bond, different ring trans double bond. So we have to find structure versus reactivity. The answer is A. Let us see how. Here the simple fact as we seen already, the cis and S transform. So you have to choose the structure which can undergo S quickly. If you look at the A, it has side chain, it is flexible, so it can undergo Diels-Alder reaction nicely. Other 3 are transite form. B is transite, C is definitely transite, D also transite. Problem is it's a rigid string, it won't convert into SC's form. So our answer is clearly A there. Then the similar question, the dienes cannot undergo Diels-Alder reaction. Again they given the 4 dienes, which is 5 member and 6 member ring. Double bonds are in conjugation, can be exocyclic or endocyclic double bond. It can be on 5 member and 6 member. So you have to find the different configuration and reactivity among them. The answer is B. Let us see how. Here the same fact you have to convert into SC's form. If you look at A, it's SC's form, so it will undergo. If you look at C, it is also SC's form, it will undergo. If you look at D, it is also SC's form. Only our answer is B, which is S transform. It will not undergo Diels-Alder reaction. Then let us look at the next question. They ask you to guess the starting material. They given the multiple products there. They given the various starting material, various diene and dienophile. So you have to guess which one will form desired product. From the question to answers, you might realize the question is really about best reactant versus product. The answer is D. Let us see how. Here you have to try all the possible products. If you look at the A, it will form Diels-Alder reaction, but it's not our required product. If you look at the B, it will also form, but it is also not our required product. C won't undergo Diels-Alder reaction because there is no diene there. D is our required product there. So it's form 4 plus 2 addition, it form our desired product. So you have to master the guessing of reacting materials. Then let us look at the next question. Starting with oxygenated thiophene with alkyne, you are heating it up. They given the 4 different products. One is substitution product. A and B are substitution product. C and D are ring expanded product. So you have to guess what is really happening with these substrates. From the question all possible answers, you might realize that the question is really about naming reaction versus SO2 removal. The answer is C. Let us see how. This is a Diels-Alder reaction in the plain side. You have to write sulfur in the bridged carbon and alkyne is the dienophile. If you do the reaction, you have bridged carbon. The only thing is SO2 removal. It's a new thing as well as extra here. SO2 removed, it will undergo aromatization. So you have 6 member ester there. The extra step is induced by aromaticity. So the answer is clearly C there, which is ester. Then let us look at the next question. They given the chlorine substitute acid chloride with base amine and a 5 member cyclopentadiene. They given the 4 different products. They have bridged carbon and fused carbon as well as substituted product. So you have to guess whether substitution or a fusion or just a cycle addition. So from the reactant to product, you might realize there might be a regioselective cyclization possibility. The answer is B. Let us see how. Here first step you are using the base. Base remove the proton. You have cumulative diene formation, kind of alene substitution. Here 2 dienophile is there. One is with dienophile, electron with diene group, which is C double bond CCl. So if you fuse it with 2 plus 2 cycle addition, you have 5 member and 4 member fusion product. It is a 2 plus 2 cycle addition, not a 4 plus 2 cycle addition. This is due to the perpendicular orientation of orbitals there. So if you look at this kind of system, you always think of 2 plus 2 cycle addition. This is specific for this alene kind of system. So our answer is clearly B there. Then let us look at the next question. They are asking number of compounds can undergo Diels-Alder reaction. Here they given the various diene. You have to guess which one will undergo, which won't undergo. They given the multiple numbers. You have to guess it. So from the question and possible products, you might realize the question is really about structure versus reactivity. The answer is B. That is number 5. We will see how. Here the simple fact again and again we are seeing is S-cis conformation. So you have to choose the compound which can have S-cis conformation. S-cis form is required. If you look at it, only 2 S transforms are there. They are rigid, it will not flip. So total number of compound can undergo Diels-Alder reaction is 5 there. So the answer is clearly B. Then the next question. This kind of reaction we seen already, but you have to look at different perspective. Here you have quinone and heteroatom containing 5-member ring. The final product is Diels-Alder product. Here you have to find the activation barrier trend in the reaction. The variants are carbon, oxygen and sulfur and nitrogen. So you have to find the difference in the activation barrier. So from the question to possible answers, you might realize the question is really about Diels-Alder reaction versus heteroatom. The answer is C. Let us see how. Here you have to know the electronegativity difference among heteroatom. If you look at it, oxygen is more electronegative than nitrogen and sulfur, so it will make the ring electron deficient. If you look at the carbon substituent one, it is not at all aromatic, no conjugation, no resonance energy. Hence, more electronegative atom don't allow the electrons to participate in the ring resonance. So if you look at the answer, the S will be the higher, then come nitrogen, then come oxygen. Carbon is the least one because it's not aromatic system. So the answer is C there. Then let us look at the next question. The question is really about the compound can undergo Diels-Alder reaction. They given the 4 different diene with exocyclic double bond and the ring double bond, which is in the cis position in the one ring, trans position in the another ring. And S is phenanthrene there. You have to find which one will undergo. So from the question to the product, you might realize the question is really about structure versus reactivity. The answer is D. Let us see how. Here P, Q, R are trans conformation. We cannot convert into cis because of the rigid structure. So it cannot isomerize, no Diels-Alder reaction. Phenanthrene is a peculiar system. Even though it's aromatic, due to the annihilation effect, middle ring is less aromatic. So what really happens is it can undergo Diels-Alder reaction. So our answer is clearly yes there. Then let us look at the next question. They ask you to guess the starting material with maleic anhydride. The product is Diels-Alder reaction. They given the 4 different starting material. All are diene. You have to guess the reactivity order. From the question and possible 4 reactants, you might realize the question is really about structure versus reactivity. The answer is B. Let us see how. Here the concept is simple. You have to produce the SS configuration. Rigid rings are always better. It can undergo Diels-Alder reaction. The linear ones are easy. It can convert into SS. The second one is very interesting because of the steric effect. It never undergo SS conformation. So 2 will be the least one, 1 will be the higher one. Among 3 and 4, it has methyl group which is electron donating group. So it will have higher reactivity than 4. Hence the order will be on B, which is first one is higher, then come third, then come fourth, least will be the second one. Then let us look at the next question. They given the 2 starting material, diene and dienophile with acid group. You are using N-bromosuccinamide. They ask you to find the product. You have to guess where the bromine substitution occurred, where the cyclization, where the lactonation happen or not, or just a simple substitution happen or not. So from the reaction to product, you might realize the question is really about naming reaction versus selectivity. The answer is B. Let us see how. Here diene and dienophile is there, cyclic product happen which is bicyclic system. Always endo is favored there. Then you are using the N-bromosuccinamide. It's the extra steps but you have to master it. N-bromosuccinamide is there, so it forms rigid carbon. It forms epoxide kind of bromination. Bromine formed at endo to avoid the steric effect. Then the COOH. Bromine is a good leaving group, so ring will be open. So CO minus attack which is near to it. So 1 is near to it. So attack happen. It form lactonization. So our answer is clearly B there. Here along with Diels-Alder reaction you have to master the extra steps. Let us summarize what we seen. Diels-Alder reaction is really about diene and dienophile and it's a 4+2 cycloaddition. So you have to master what is required for diene. It should be with SS configuration. It should be electron rich, it should be steric effect free, and reactivity of cyclic is higher than acyclic. Dienophile is easy, it should be electron deficient. Then the 3 important facts you have to know here is cycloaddition is syn addition, both carbon approach at same phases. Then the product will be always endo in the case of cyclic reaction. In the case of regioselectivity, orthone product is favored than meta. That's all from this episode. I hope it was useful. Thanks for watching. If you found my video is useful, subscribe and share.